So now that we've talked about a little bit of what a limit is and given you a little bit of an idea of what a limit is, we now want to talk about how to do limits numerically. And that's going to help us get a little bit more of an understanding of a limit. Again, a limit is worried about what is happening to the function as we approach the value. Again, the limit is not really interested in what happens at the value, although sometimes it turns out to be the same as the function value, but not always. So as a first example here, let's say we want to compute the limit, and we're going to look at limit as x approaches 3 of x squared minus 5x. And we're going to look at this numerically. So to look at it numerically, we're going to need to begin by making a table. So we want to construct a table. So we're going to be looking at values of x and f of x. Now as we make this table, we're going to be wanting to look at values that are close to 3. So when I mean close to 3, I mean really close to 3. So not looking at x equals 1, x equals 2, x equals 4. No, we need to be closer than that to get a feeling. So I'm going to start with maybe 2.9. That's pretty close to 3. And I'm going to pick a couple more values a little bit closer. So 2.99, that's even closer. And then one more that's even a little closer, 2.999. All the way within 1,000th of the actual number. And in the middle here I'm going to write 3, and I'm going to put a quick little dash there because I'm not actually going to evaluate 3. I'm not actually going to evaluate 3 here. Because limit doesn't worry about what happens there, just what happens around. So those were all values that were bigger than or smaller than 3. We're also going to look on the other side of 3, so we want some values that are a little bit bigger. So here, kind of keeping the pattern of tenths, hundredths, thousandths, I'd have thousands, 3.001, 3.01, and 3.1. And then we just want to go through and evaluate. If you check in the course notes from Brightspace, you will find the course notes. And in the course notes, there is some explanation about how to use the table feature on a graphing calculator like a TI-83, TI-84. So if you have one of those, you can definitely save yourself a little bit of computation time by using the table feature on your graphing calculator. So using that feature, or you can go through and do each thing individually one at a time. So as we go through and evaluate, if we plug in 2.9, we're going to find out that it evaluates to negative 6.09. And then if we continue on 2.99, we get negative 6.0099. Might kind of start seeing a little pattern here emerge. Because now when we come to 2.999, we get negative 6.000999. And you could probably guess, and you could check on a calculator if you did it to the nearest 10,000, 2.9999, then it would probably come out 4 zeros followed by 4 nines. Is that what it's going to be? I don't know. I haven't checked it. And then we're going to go and pick values that are bigger than 3. So I started with 3.1, and when I do that, I get 5.89. And then we plug in 3.01. I get 5.9899. Okay. And then finally 3.001, I get a negative 5.998999. Now on your graphing calculator, if you're using the table feature, to get more than like 2 or 3 decimal places, you do have to use the cursor to highlight the number, and then it will show you that number in its expanded form so that you can see that. Again, if you haven't done so yet and you do have a graphing calculator, I would encourage you to try to work on that and see how to handle that. Okay, and so that's our table feature. Now the whole point of doing all this computation was so that we can see what this is approaching. or is it approaching a value? Is it settling in towards a particular value? And you can see here that as we look at this from the two sides of 3, stuff below 3 and stuff above 3, it sure looks like it's settling in to the number -6. And so that's what we would say this limit is. Now it happens in this example that if you plug 3 into that function, you will get -6. But here we're talking about numerically, and so we do want to evaluate. We have to complete the table on a problem like this. And so we can see it is approaching -6. So this thing does in fact have a limit, and the limit is, in this case, -6.